Guys, I just wanna clarify the concept of my last video, okay? And I'm gonna show you the principle behind what I've done, redoing it in a simpler way and with exaggerated dimensions, okay? So let's go here. What I'm gonna do, it's important for you to know that it's can be done in any CAD software, okay? It's very easy. I'm using just simple commands. Okay. So let's start doing a simple airfoil with a 15 centimeter chart. Okay. I'm just gonna draw it randomly. Okay. This is just for you to show. Okay. Now let's go into perspective and extrude this curve, okay? Like this, okay. And we have this simple surface, okay? Now we are gonna offset this one with an exaggerated dimension, like 5 millimeters, okay? And it's done, okay. Now let's hide the curve is not needed anymore. Let's hide this one, okay, and let's cut this piece, okay. It's gonna be easy. Let's draw a rectangle, okay, and we'll use it as a trim tool, okay. That's it, okay. Now let's cap planar holes, okay. Let's use, no, not now, okay. Wait a second. Yes, okay. Solid cap planar holes, okay, and make it detached, okay. Now let's go here and do this one. Let's trim it again, okay. Wait a second, I can do better. I'm gonna use some magic here. I'm gonna attach this curve here, okay. Again, these are, if you don't know rhinoceros, this can be alien techniques to you, but it's nothing special. You can do this obviously with any CAD software, okay. Now let's trim this one, okay, and trim this one, okay. Something disappeared, no, okay. Now let's close this one, wait, okay, and that's okay. Now some magic, okay. We are gonna draw a rectangle here, okay. Let's make it a little bit inside and extrude as a surface, okay. And we are done, almost. Let's stitch this one together, okay. Okay, now let's trim this part here, okay. No, wait a second, didn't work. Let's punch a hole here, okay. And now using this one, let's extrusion, okay. I'm just cutting here to create you're going to see now, okay. everything's correct. Okay, let me check it if it's watertight. Okay, let me show you this one again, and using a mutual trim I'm gonna cut this and this. Okay, and we are done. Okay, this is all what you need to know to do all what you need to know on how to do the truss airfoil like the last video. Okay, this is a simple surface. Okay, the dimensions are exaggerated. Okay, but it's somehow isomorphic to what I've done previously. Okay, the main feature, it's this one. Okay, let's make a clipping plane here. Okay, let's activate it. Okay, the main feature is that every section it's a closed curve with no islands. Okay, as you can see, when I reach the box, okay, the printer, what does it do? It spiralizes this one. It goes the extruder like this movement, like this. It creates this one, this one. This is the truss. Okay, this is the bottom layer. This is another side of the truss. Okay, it goes back here, up to the airfoil, to the upper part, and it goes like this. It make a layer. Okay, it goes down, make the same thing, and it goes on. Okay, when you make more of this, okay, for example, you make wait a second, gonna show you, wait a second, just to be clear. If you make another one here, okay, just to show, as you can see, when the printer goes here, it creates this truss. Okay, this truss. Okay, and here the other side of the truss. Okay, and it creates that structure that you can see in the print. Okay. Okay, there is nothing more to this. Now I'm gonna show you with some drafting the real dimensions. Okay, I hope this make you understand better what I've just done. Okay, so here we can see a section of the geometry with the exact dimensions. Okay, you can see the hole through the skin are 0.04 millimeters, and the distance of the boxes from the skin are 0.65 millimeters, and here are the dimension of the front spar. Okay, and the cut. Here we have the, I didn't show you in the video, this is the spar. Okay, running through the wing. As you can see, it is just a fold in the skin going down. Okay, it reaches the bottom with an offset of 0.65 millimeters. Wait a second, I'm gonna show you. Okay, as you can see here, and the distance between this surface and this is 0.04 millimeters. Okay, now I'm gonna show you again the main feature of this geometry with this Rhino command. Okay, not this one, it's this one. Okay, I have extracted a slice. Okay, and as you can see, here, this is a closed curve, okay? And this is the main feature of every geometry that can be spiralized in the slicer, okay? You can follow the path and see that it's in fact closed, okay? The same is done here, okay? Here it's more apparent, okay? It's more visible. A second. As you can see, for example, the extruder starts here, it goes like this, the outer skin, it makes the spar, okay, goes down, then up again, okay, it goes on with the skin, and it goes back to the beginning, okay. The importance of having these dimensions is that the walls have to stick together firmly, okay? And that's all, you know. If you have a different nozzle diameter, these dimensions must be changed. I don't know which are correct for which nozzle size, but you have to experiment yourself. Okay, that's all. I hope you can understand better what I've done and the design of this complicated geometry.